All right, folks, I'm ready to get started. Welcome back, everybody. Welcome to the beginning of the third week together. Um, we're finally getting to know each other decently. I don't know. It's been 2 weeks, but 3 weeks is a good amount of time. We're moving forward. We are starting to get into like the meat of the semester. So just keep that in mind. Don't let things slide. Like, make sure that you are understanding things as we move along. Make sure everything's being done as we cover it versus like letting things pile up and getting things backed up, because it is a recipe for disaster in this class if you do that. If you do not make sure you're staying on top of what we're covering in class, that you understand it the right way, that you are able to do the calculations that I do. um, the homeworks, make sure you understand the concepts there. Like, don't let things slide, because again, like, even though it hasn't gotten too crazy yet, eventually like you're gonna have this crazy theory over here and this model over there, and like weird kind of tricks you need to do over here to be able to get to over here, and it's just, even though you can individually understand these things very easily, when they start to pile up on each other, then if you're not in tune with the differences between them, what makes one theory work and one model work versus another, then that will eventually lead to confusion, and you won't have enough time to kind of like sort it out in your head and get to the point that you need to get to of understanding these things, so you can do well in the class, etc. So don't let anything slide, and of course, also you have other things to do. So like, it's important to, like, if you have free time, take advantage of it. Focus on getting everything you have to do done first before you do anything else, and then if there's extra time, enjoy your life, whatever. But this is not the time to focus on enjoying your life. It's time to focus on getting work done and doing the best you can here, which you signed up for willingly. Summer will come. You'll have a break. You'll be able to take your mind off of this stuff um, and reboot. But like, we're not there yet, and it's going to be a bit before we are. So um, give everything you have now. You'll feel great about it in the end. You'll feel great about it in the long run. You'll learn what you need to learn from this class. You'll apply it in the ways that it needs to be applied in the future, and you'll pave a good path for yourself forward. Um, versus just having a bad experience, which I don't want you to have. All right? Do the things I'm asking you to do now, or you should be telling yourself to do now, in order for you to, have a good semester. I want to have a good semester too, because in the end, like, it bothers me that, people don't wind up doing that great in a class like this towards the end. There's always a group. And you'll start to see it reflected in like the empty seats. Like there are a few people that will be on top of things, but a lot of these people, they just like are casual class takers. They think they can just handle this, just like on the side, which is a mistake. But like, like a class like this doesn't change for the people in it. It never will. This class is what it is. It is what it will always be. And so you need to change for it. You need to adapt to its requirements. If you haven't been pushed hard in a class before, then you need to learn how to do that, so that you can then realize what you're capable of, and take that moving forward to bigger challenges in your life. So, all right, I want everyone to do well. Ultimately, is the point of all this. I hope you do well. All right. Anyway, so today we're going to start jumping into things that are going to be a little bit more abstract. It's the rational consumer choice model, chapter 3. We will cover this chapter in 3 lectures. So the rational consumer choice model is essentially a way for us to model the behavior of an individual deciding to consume, given that they face prices in the market, and they have a limited amount of income to buy the things that they want to buy. So in most models that you see out there that try to explain any part of the economy, be it the economy as a whole, just one market, just one asset price, you will always see components of households maximizing their utility subject to budget constraints, and firms maximizing their profits subject to cost constraints. And those will represent the behaviors of like the majority of like consumers and producers in the economy. And so that's how we account for that within a model, and thus can then think about the effects of those regions of the economy on a price, on an industry's profits, on the economy's output as a whole. And so what this chapter does is it starts to build, well, it builds up and establishes the model that we use to establish that equilibrium for individual households that are consuming the things they most want to consume and can afford. And so in order to do that, we have to kind of build up the components of the model. So the first component we'll build up is the opportunity set or budget set, right? So that will represent, as far as consumption goes, like what a consumer has to deal with outside of themselves. They have to deal with the fact that the things they want have prices, and they also have to deal with the fact that they only have a limited amount of income to spend on these things they want. So we need to define what that looks like. We'll define it in a simplified setting where there's only a couple of goods with prices first, and we'll lightly start to touch upon the math, but a lot of this initially will be more intuitive, like using graphs to sort of get us to like what we mean by what this model is doing. And then next week on Tuesday, we'll do numerical examples, which will require calculus. So I'll do a quick review of calculus, and then that'll get us to like the next level of understanding of this model. This is a model that you may or may not have already learned in your introductory micro course. I know in my micro course, it's covered as an appendix to a chapter, but I do cover it in my class. So I don't know if it's been covered in your class before. So this may be completely new to you, but if it isn't, it will definitely require you to take your understanding further than it has already been taken. So again, we're modeling the decision to consume of consumers given that they face prices in the economy and they have a limited amount of income. So we'll establish what it means to have an income and what changes in that income may look like. And then we'll briefly talk about how we can complicate the world a little bit by making one good in the two good world represent like the remaining income after spending money on something that somebody wants. They have a remaining amount of income, and that's what their other good will represent. And then we'll go into the more abstract portion of the model, which is meant to represent the second component that result in this equilibrium for individuals. So again, I mentioned that we all face prices and we have income, and that limits how much we can buy. The other side of the coin is like what we want to buy. What do we prefer, right? So then we need a framework to represent our preferences in the model. So like the preferences of an individual, they have to be as general as possible. So they are. We consider the most general case. So that's what the last part of today's lecture will be. We'll be establishing that side of the model, the way that we can establish the rules of representing how we can graphically have, and then ultimately mathematically, a representation of an individual's preferences for goods. So the interaction of the preferences and the budget constraint and the prices will get us to a consumer equilibrium where they are maximizing their utility, the happiness, the satisfaction they get from consuming, subject to their budget constraint. The fact that they can't buy everything they want, they have a limited amount of income. That equilibrium is the equilibrium that is generally representative of like a stable household sector in an economy. And that is what, again, is the main component of most models that try to track any aspect of the economy, be it one price, industry, or the economy as a whole. So that's what all of this is about. It's going to get pretty abstract, but hey, it is what it is. And we have to build it up very precisely. So it's kind of like explaining stereo instructions in a sense, So just kind of try to stay with it. And then so we'll talk about the equilibrium on Thursday. by interacting the preferences and the budget set, and then on next week we'll do like the math that I'm expecting you to be able to do to reflect the model, just a more sort of practical application of it in the way that it might look, in these uh, uh, areas that you are likely interested in the long run, like finance and economics and information systems. All right. There was a question about homework over here. Okay, good. We're good. I like that. I like that. I like answering your own questions. I appreciate that. Yeah. No, they're due the middle of next week. Yeah, just because of the ad drop stuff, I didn't want to put any weird people in weird positions. But yeah, the middle of next week. Questions?
So earlier you said that if you have one try and that's it.
Yeah.
Okay. As of now, it says you have unlimited attempts.
Okay.
Okay, which is cool because I accidentally clicked on it.
Well, that's no. You can have unlimited attempts, but like the first attempt will register as the score that I look at.
So it's not timed?
No. The homework is ultimately pretty frivolous. Aside from like the content itself, it's just 10 questions and multiple choice. I give you the answers. It's meant just as a sign for me to get an indicator that you're doing something outside of class. But like I mentioned, like the practice problems are your true homework. And so I leave that up to you, how much you're going to be going through them and really understanding them. And so that's why I don't make the system homework too weighty. But still, the principles that are covered are important, and you should know them, and it will help you, at least on exams. So just keep that in mind. But yeah, like there are however many attempts, whatever. But and then also if there's like system errors or whatever, and you miss a point here and there, don't worry about it because I don't care about the points from the homework. As long as you're doing the homework, if you're missing a couple points here and there in each one, it doesn't matter. Because I'm giving you the answers. Obviously, I'm telling you it doesn't matter by giving you the answers. What does matter is that you are doing it. And so there's a clear record that you are putting in some effort into something outside of this class, which I need. That gets taken care of. But ultimately, what will determine your performance in this class are the exams. And so prepare for the exams, do well in the exams, and you will do well in the class. And get the paper done too. All right, so let's talk about rational consumer choice. So the learning objectives is to describe the consumer's budget constraint, the set of all combinations of goods that can be purchased with given income and prices. We'll show how budget constraints change when income and prices change. Then we'll jump to the second part of the model, which represents the preferences of a consumer, which can be represented by what's called an indifference map. And then we'll show how the budget constraint and the indifference map interacts. And again, the preferences are represented by the indifference map. The prices and income are represented by the budget constraint. And then interacting the two will determine the optimal combination of goods to purchase, the equilibrium consumption bundle for an individual consumer. All right, so let's talk about this first component of the model, the opportunity set or the budget set. So consider a world with only two goods. Let's say those two goods are shelter and food. So we've got food on the y-axis and shelter on the x-axis. So any combination of the two goods can be represented as a bundle. It's a particular combination of two or more goods. So let's say there's a bundle here at point A, and it represents 5 square yards of shelter and 7 pounds of food. So it's telling us also per week. So these are numbers per week, and I'll mention why that is in a second. And let's say we have another bundle where instead of 7 units of food, there's 8 units of food, so there's more food, but with that extra food comes less shelter. So 3 units of shelter and 8 units of food. So these consumption bundles represented by these ordered pairs. By convention, the first number of the pair represents the good measured along the horizontal axis, right? So just your standard coordinates for the XY Cartesian plane. And then the second number represents the number on the y-axis. So more generally, you can generally state a consumption bundle in this very specific world we're living in which only food and shelter are available, by this ordered pair where you have some amount of shelter and some amount of food represented by S naught. S subscript 0 is described as S naught. So S naught and F naught will denote the bundle with, again, some amount of shelter measured in square yards per week and some amount of food measured in pounds per week. So note that the units on both axes are what are called flows, which means physical quantities per unit of time. We specify that there's a certain amount of food consumed per week, that there's a certain amount of shelter used per week. Consumption is always measured as a flow in order to gauge size. 4 pounds of food a day is a lot, but that amount a year is not, so you have to specify the time period. But I won't always specify, but just like to be precise in some like analytical report or something, it's important to be precise about it. All right, so let's let M equal the consumer's income. M will generally denote income in economics anything. So any economics course you're in, if we're talking about income, we want to represent it by some variable. We'll use the letter M. So if we assume M equals, let's say, $100 a week, and that this consumer, she can spend all of it on some combination of food and shelter, so some consumption bundle. But she can't just buy as much as she wants, even though she wants to, because, again, things have prices, right? So the shelter has some price, which we denote price subscript S, P subscript S, as the price of shelter. And we can assume, in this case, that the price of shelter, let's say, is $5 per square yard per week. And we have some price for food, which in this case can be denoted by P subscript F. And we'll assume that P subscript F, the price of food, is equal to $10 a pound per week. So if the consumer spends all her income on food, so if she decides, I don't need shelter, I'm just gonna eat. So in order to do that, that means that given the amount of income, which is 100, if we divide that by the price of food, then we can get the most amount of food that this person can buy, right? With her income and the price she faces for food. So if you divide your income by the price of food, in this case 100 divided by 10 bucks, that gets you 10 pounds of food per week. And that amount can be represented by this point here, where the consumer is consuming, again, 10 pounds per week and 0 units of shelter. So it's also going to be the y-intercept for our budget line in a second. And if the consumer spends all her income on shelter, then instead she would, again, not consume any food. Well, she'll divide her income, M, divided by the price of shelter, which is assumed to be $5. So 100 divided by 5, 20 square yards of shelter per week is the most that she can buy if she only decided to buy shelter with her $100 that she earns. And that point can be plotted here, where again that represents the fact that 0 food is being consumed and 20 units of shelter, square yards per week of shelter are being consumed. Now the consumer is also able to purchase any bundle that lies along the straight line that joins these 2 points. And so this line is made up of combinations of the 2 points that the consumer can afford and spends all her income on, given that, again, she faces these prices, $5 for shelter, 10 bucks for food. So this line is what we call her budget constraint. It's a set of all bundles that exactly exhaust the consumer's income at given prices, also called the budget line. So if you remember from your micro course, in micro we cover this model called the production possibility frontier. And this is essentially the same concept, just translated to consumption rather than production. So the production possibility frontier is basically a line as well in a 2-good world where only 2 goods were produced, and those combinations along the line were the most that you can produce of both goods if you're using all of your resources to produce, right? You're using your technology and your productive resources. So again, this is another way of looking at the budget constraint is as the consumption possibility frontier. How much is the most that can be consumed given the resources that one has, one's income, and also the fact that there's a trade-off between the goods that's represented by the prices of the goods. All right, anyway, so recall the slope of a line, just in general, is, of course, the rise over the run, which is the change in x over the change in y over the change in x. So one way of representing the slope of this line is just to take the ratio of the intercepts. So if we look at the most amount of food that can be purchased if she only bought food, then that will be our y-intercept. So if we think about, let's say she's consuming shelter, just shelter. So she's consuming 20 units of shelter. In order to consume 10 units of food, she has to give up 20 units of shelter. So the change in x is 20, and the change in y is 10. So the slope of the budget constraint can be calculated as the ratio of the y-intercept to the x-intercept. The negative represents that there's a trade-off. As you consume more shelter, you have to give up food and vice versa. So again, it's the rise over the run. So we know that our y-intercept represents, again, the most that she can buy of food if she only bought food, which is income divided by the price of food. So that's the y-intercept. X-intercept, the most she can buy of shelter if she only bought shelter. Income divided by the price of shelter, m divided by ps. So that is our x-intercept. So m over the price of the food divided by m over the price of shelter, with the negative, again, to represent the negative slope of the line. Standard mathematical property of ratios, when you have a ratio divided by a ratio, that's equivalent to the top ratio times the reciprocal of the bottom ratio. So this is equivalent to the top ratio times the reciprocal of the bottom ratio, so equal to income divided by the price of food times the price of shelter over income. The price of the, incomes cancel out here, and we're left with this expression here, which is another way of representing the slope of the budget constraint, which is negative the price of shelter to the price of food. More generally, it's negative the price of the good on the x-axis to the price of the good on the y-axis. And what it represents is the relative price of one good to the other. It represents the price of shelter that you need to pay in order to consume more shelter in terms of food. So as if you're trading them off in real terms. Remember, any prices in this class are always going to be in real terms, as I mentioned last time. So all prices are calculated. Even though they're calculated in numbers, they represent an amount of the other good that can be traded for the good that we're considering, or other goods, if we're considering a world with more than two goods. But in this case, we're just considering a world with two goods. So essentially what this tells us is the exchange rate of 1 unit of shelter for food in this economy. Again, reflecting the prices that are set in markets for shelter and food. So these prices were set in individual markets for each of the goods. There's a demand, there's a supply for both of them. There's an equilibrium that's being set up, and that is where we get these prices from. And then the slope of this line of our budget constraint in this world where only food and shelter are being purchased by a consumer, the slope represents the exchange price of food for shelter. So in this case, it's negative 5/10, or again, the price of shelter 5, the price of food 10, but you can obviously reduce that down to negative 1/2. So that means that 1 additional unit of shelter can be traded for half a unit of food. So 1 square yard of shelter per week is worth half a pound of food per week in exchange value in this economy. So the slope of the budget constraint is thus the negative ratio of prices of the two goods. It's the rate at which food can be exchanged for shelter. In the language of opportunity cost, we would say that the opportunity cost of an additional square yard of shelter is half a pound of food. Yeah. Then you would take the reciprocal, right? No, it would still be negative. It would just be 2 over 1, right? Yeah, so the opportunity cost of shelter is negative 1/2. The opportunity cost of food is just the reciprocal of this. So that's another way of looking at it, by looking at it from food as you're increasing your food consumption. How much shelter do you have to give up? It's the reciprocal of this. So it will be negative 2 units. So one unit of food requires 2 units of shelter in exchange. The opportunity cost of 1 unit of food is 2 units of shelter, and vice versa. So again, like, generally what's important to take away from this is that the slope of the budget constraint, which generally a slope of any line is going to be the change in y over the change in x, but given what the line means and how there's income and prices embodied into the slope, and we can therefore derive this expression here, then when we get to this expression, which is going to be important in this class and in this model, you have to be able to recognize that the price of the good on the numerator is the price of the good on the x-axis, and the price of the good on the denominator is the price of the good on the y-axis, which is contrary to what you normally think of intuitively as a relation between the variables in just your standard slope of a budget constraint. So it's easy to get mixed up if you don't know this. So it's good to know how to get to that point, in case you don't want to memorize that, which is always good. It's going to have to memorize things and to be able to derive them. All right, so in a two-good world, the opportunity cost of one good is the reciprocal of the opportunity cost of the other good, as I said. So the opportunity cost of food, in this case, is going to be the reciprocal of this. So instead of negative 1/2, it's going to be 1 over 0.5. I got rid of the negative, but it's still there. I'm going to sometimes leave out the negative, but it's just because it's assumed that there's a negative, there's a trade-off there. And so whenever we're talking about opportunity costs, we're talking about something being lost to gain something else. So there's always a negative there no matter what, even if I'm showing it or not. All right, so in addition to being able to buy any of the bundles along her budget constraint, the consumer is also able to purchase any bundle that lies within the budget triangle bounded by the budget constraint and the two axes. So the green triangle here is what's called the opportunity set. So G is one bundle that costs $60 a week in this case. So G represents only 5 units of food being consumed and 2 units of shelter, which is well below the consumer's income, right? 5 units of food times 10 is 50. 2 units of shelter times 5 is 10, so that's $60, less than $100. So the bundles on or within the budget triangle are also referred to as the feasible set or the affordable set. There's different names for things in economics. But feasible, basically reflecting the fact that they're achievable, affordable. They can be purchased, right? With the $100, you can purchase goods along the budget constraint, which represent you exhausting your income, and you can purchase combinations of the two goods within the triangle, which represents you not exhausting all of your income, or this abstract consumer not exhausting all of her income. So the affordable set, again, is bundles on or below the budget constraint, bundles for which the required expenditure at given prices is less than or equal to the income available. So you could also have bundles like E, which lie outside the affordable set, the budget constraint. So E represents more of both goods that can be afforded by the $100 given the prices that are faced by the consumer, and so they are infeasible or unaffordable. All right, so if S and F denote the quantities of shelter and food, respectively, the budget constraint must satisfy the following equation. We assume in this class that that the consumer is exhausting all of her income, and therefore she is consuming a consumption bundle on the budget set, right? And so therefore her income has to equal the value of the amount of shelter she purchases, which is the price of shelter times the amount of shelter, plus the value of the food that she purchases, which is the price of food times the amount of food she buys. The consumer's weekly expenditure on shelter plus her weekly expenditure on food must add up to her weekly income. To express the budget constraint in the manner conventionally used to represent the formula for a straight line, which is the slope-intercept form, we solve the equation for f in terms of s. So we have to solve for food in terms of shelter because we assume food was on the y-axis and s was on the x-axis. So taking this expression here, we have to do some algebra, subtract this term from both sides, and then we are going to divide both sides by the price of f. Doing that gets us to this expression, f equals the intercept, which is the most that this consumer can buy if she only bought food, so m divided by the price of food, minus the slope of the line, which we know is the ratio of the price of shelter to the price of food, times the variable shelter, right? In this case, independent variable, just given how we graphed it. So this slope-intercept form of the line is the equation for the budget constraint that we just were looking at. Again, the information you need about the slope is here, and also about the intercept is here, things that we talked about without that equation. All right, now that's the nature of the budget set. That's how it looks mathematically. That's what all the components of it mean. Now let's talk about what happens when the budget shifts due to a price change or an income change. So the slope and position of the budget constraint are fully determined by the consumer's income and prices of the respective goods. The slope of the line represents the trade-off that the markets are presenting to the consumer, given that prices are being set, and then you take the ratio, and that gets you to the relative price or the opportunity cost, right? So that exchange, that market exchange rate of food for shelter is embodied in that information, the slope of the budget line. So changing any one of the factors, either the amount of income or the prices of the goods, will lead to a new budget constraint. Suppose the price of shelter goes up from $5 to $10. So the price of shelter goes up from $5 to $10 here. What's going to happen to this intercept? It's going to shift to the right. It's going to shift inward, right? So the price is going to go up from $5 to $10. That means that the total amount that can be purchased of shelter is going to decrease, right? M divided by a bigger number, right? So we know the slope of the budget constraint is the ratio of the price of shelter to the price of food. This is our old opportunity cost for shelter. It's 1/2 a unit of food. And now we have a new price of shelter, which is 10. So therefore now the trade-off has increased, right? Now because the price of shelter has gone up, that means that you need more food to exchange for it in order to be able to get 1 unit of it in real terms in the market, right? So that means also that you're going to have a steeper slope. The slope has gotten bigger, right? So we know that the line will shift in just from that. We also know by analysis of the intercepts that that's what will happen. Since both weekly income and the price of food are unchanged, the vertical intercept of the consumer's budget constraint stays the same. So this is not affected. The horizontal intercept does change, as we know. Again, you have your income divided by the price of S. We have 100 divided by 10. So now the most that she can buy is 10 units of shelter. So that's our new intercept there. Connecting that to our old y-intercept gets us to our new budget constraint. So as you can see, the increase in a price will rotate your budget constraint in depending on whether it's the price of the good on the X or the Y axis will determine which of those intercepts will be rotating in. Quick exercise, show the effect on the budget constraint of a rise in the price of food from $10 to $20 and a rise in the price of shelter from $5 to $10. All right, so this is going to highlight a special relationship between changes in prices and changes in income. So let's look at the effect on the budget constraint of a rise in the price of food from $10 to $20. So we know what happens with the rise in the price of shelter from 5 to 10. We know that that's going to happen. A rise in the price of food works similarly. The vertical intercept changes. In this case, $100 of income divided by 20 bucks gets us to 5 pounds a week of food that this person can buy in total. What we see here is that the price of shelter has gone up by 100%, and the price of food has also gone up by 100%. So both of them have gone up by 100%. We've shifted both of our intercepts, and now we have a new budget constraint. The important lesson of this exercise is that the slope of a budget constraint tells us only about the relative prices, nothing about prices in absolute terms. So we see that we essentially had a parallel shift in the budget line as a result of both prices changing in the same proportion and in the same direction, which is equivalent to the income of a person basically being decreased. When the income is decreased, you also have a parallel shift of the line inwards. Essentially what this is telling us is that in real terms, the exchange rate between the two goods hasn't changed, but because the price of both of them has gone up, the real value of your income, the amount that you can purchase, what your income represents in terms of goods that it can be traded for, has gone down. So the slope of the budget constraint before was -1/2, and now the slope of the budget constraint with a doubling in price of shelter and a doubling in price of food gets us to once again the same slope. So the exchange value between the two goods, the relative price of the goods, has not changed, even though both prices have, and that is again because they have both changed in the same proportion. So when the price of food and shelter change in the same proportion, the opportunity cost of shelter in terms of food remains the same as before. Now let's look at an income change. So the effect of a change in income is much like the effect of an equal proportional change in all prices. Suppose income goes down from $100 a week to $50 a week. So here's our original budget constraint. We assume the old prices, but now we're saying that income has gone down from $100 to $50. So just thinking about what happens to the intercepts, we know that the horizontal intercept is now going to be $50 divided by 5, so that's going to be equal to 10. And the vertical intercept is going to be equal to 50 divided by 10, so that's going to equal 5. And there's our new intercept there. So we have the exact same effect when our income has been halved. So it's gone down by 50% rather than doubling both prices. So you essentially have the same effect in this economy, reflecting the fact that ultimately what matters is like the real exchange between the goods. So the new budget constraint is parallel to the old budget constraint with the same slope. In terms of its effect on what consumers can buy, cutting income by 1/2 is no different from doubling each price. The same budget constraint results from both changes. All right, so that's kind of like the mechanics of the budget constraint, the information that's embodied in just a simple equation for a line. There's a lot you can get out of that by making assumptions about what that line represents, making assumptions about how that line correlates to what we understand reality to be for somebody that's buying things. And the information, the intuition we gain from it is actually strongly correlated with what we see in the actual economy. So such a simple version of reality can represent a lot, and it can have a lot of information, tell us a lot about the way behaviors that we're interested in might be behaving. Okay, so let's talk about complicating this a little bit more, but leaving the simplicity of it as it is. Meaning, we want to make the world more complicated. We want to make it a world where there's more than two goods, but we don't want to go beyond the two good case. So, in its most general form, the consumer budgeting problem can be posed as a choice between not two goods, but n different goods, right? All of us face an unlimited amount of goods that we can buy, each having an unlimited amount of corresponding prices. And again, we're faced with the decision to purchase what we purchase, our own consumption bundle, given the prices that we face and the fact that we're limited by our incomes, right? That's our budget line. It's limiting our ability to consume all of it. We can only consume what we can consume. Some consumption bundle along those lines that will exhaust our income. We don't assume saving in this class. So if you didn't exhaust all your income in the model, then and you weren't consuming on the budget line, then there would be some savings, right? There would be some income that you don't spend. We don't assume that here. We assume that consumers in this very simple model exhaust all their income. All right, so with only two goods, n equals 2, the budget constraint is a straight line. With three goods, it's a plane. So you have another variable in there, and that would be represented by a three-dimensional geometric figure. When we have more than three goods, a budget constraint becomes what mathematicians call a hyperplane, or a multidimensional plane that cannot be physically represented. So it cannot be this. It's difficult to represent this multidimensional case geometrically or graphically, as it were. So this economist, Alfred Marshall, that I mentioned before, who came up with the supply and demand model as well, who put the dependent variable on the x-axis back before that was standardized to be on the y-axis. He did come up with this that kind of helped us to sort of solve this problem of like hyperdimensionality by proposing a simple solution by saying that the consumer's choice is between a particular good, one good that we can call X, and then an amalgam, a combination of all other goods that we denote Y. So like the second good represents everything else we can buy besides the X good that we're interested in buying. So this other good is called the composite good. So in a choice between good X and numerous other goods, it's the amount of money the consumer spends on all other goods. By convention, so it's just a standard assumption that we make about the composite good. Its price is $1 per unit. So by assuming that the price is $1 per unit, allows us to think of it as like money, the leftover money. Each unit is $1. Its price is $1. So again, this enables us to think of the composite good as the amount of income the consumer has left over after buying good X. Equivalently, it's the amount the consumer spends on goods other than X. So suppose the consumer has an income of M, some amount of income per week, and the price of X is PX. The consumer's budget constraint may then be represented as a straight line in the XY plane, again, X being the good on the X-axis, and then our composite good is on the Y-axis. So M is equal to, again, the price of X times X, the total value of X that's consumed, plus the total value of Y that's consumed. We know that the price of Y is equal to $1, so we just plug that in there, and then we get this expression here. Because the price of a unit of the composite good is $1, a consumer who devotes all his income to it will be able to buy M units, right? So if the consumer does not buy any units of X, so this is equal to 0, then M units of the composite good will be purchased, which means that their entire income will be left over. So you have M divided by the price of Y, which is equal to $1, which is equal to M. Alternatively, if he spends his entire income on good X, he'll be able to purchase the bundle M divided by PX, right? Income divided by the price of X, the most amount of X that can be purchased if she only purchased good X, and 0 of the composite good, 0 of the leftover, 0 remaining income. So that's that point over there. So the slope of our budget constraint is a negative ratio of the price of the good on the x-axis to the price of the good on the y-axis. So we know the price of the good on the y-axis is equal to $1. So therefore, the slope of our budget constraint is equal to negative the price of x when we're thinking of the y good as the composite good, the leftover income. Quick practice problem, just to think about the budget constraint, the composite good. Your weekly income is $630. A movie show costs $10. How many shows can you afford per week? 63, right? 630 divided by the $10, which represents, so if we put movies on the x-axis and the composite good on the y-axis, it represents the most movies you could purchase. Let y be the amount of all other goods that you spend on money. So I'm not telling you the good is the composite good, but because I'm describing it in this way, you know it to be the composite good, and therefore you know its price to be equal to $1. So if you plot y on the y-axis and movie shows on the horizontal axis, what is the slope of your budget constraint? So our composite good, 630, right? That's how much our income is, right? 630 divided by 1. Basically, if no movies are purchased, you have $630 left over, right? Your income. We know our income is equal to the value of everything that's purchased. Income equals 630. X is movies. Price of X is 10. Composite good is Y. Price of the composite good is $1. So plugging this information in, we have, again, 10x plus y equals 630. If we get this into slope-intercept form, we can get the slope of our budget constraint that way. So subtracting 10x from both sides, you've got y equals 630 minus 10x. Minus 10 is the slope of the budget constraint, right? So that's what we just figured out there, and we know it's negative 10, which we also could have figured out by taking the ratio of the vertical intercept to the horizontal intercept, which again, vertical intercept, the most of y you can buy, and horizontal intercept, the most of x you can buy, and then just doing a little mathematical manipulation to get the m's out of there, we get to our expression for the slope of the budget line, which is negative the price of x to the price of y, which will be very relevant later when we talk about the equilibrium for this model. So I'm trying to really just drive it home what this is. Like it's simple, and I'm repeating a lot, but it's meant to kind of get you really in tune with it so that you can hold on to it and as we move forward through the rest of the model. All right, so negative the price of x over 1 is negative the price of x. It's negative $10. So that's another way to get the slope of the budget constraint. So there's different ways of getting it, and I highlighted them here. All right, now that's the budget constraint. That's basically everything you need to know as far as like how it works, what it represents, the different things you can do to manipulate it, the information you can extract from it, etc., etc., etc. All right, now let's turn to modeling a person's preferences, a consumer's preferences for things, which is a very abstract thing, right? Like we feel good about something versus something else. What does that mean? How do we translate that to like a graph? Well, you have to be very general about it, and you have to be very specific about the rules of how it works. All right, so we know the budget constraint summarizes the combinations of bundles that the consumer is able to buy. Its position is jointly determined by income and prices. From the set of feasible bundles, the consumer's task is to pick the particular one she likes the best, the one that's most preferred, the one that gives her the highest amount of utility, satisfaction. Utility is what we use to embody that satisfaction, happiness that we get from consuming. To identify this bundle, we need some means of summarizing the consumer's preferences over all possible bundles that she might consume. So let's again begin by considering a world with only two goods, food and shelter. And we're going to establish what's called a preference ordering, a ranking of all possible consumption bundles in order of preference. A preference ordering enables the consumer to rank different bundles of goods in terms of desirability or order of preference. And that is measured in utility, which is satisfaction, which we'll talk about in the next class. I don't think I introduced utility today. All right, so consider two bundles that could be purchased. Again, each representing a combination of the two goods, shelter and food, A and B. So there's one bundle. Let's say it's 4 square yards of shelter, 2 pounds of food per week. And then here's another one. That one has 3 square yards of shelter and 3 pounds of food. So 1 less square yard of shelter, 1 more pound of food. So 2 different bundles there. Knowing nothing about a consumer's preferences, we can say nothing about which of these she will prefer. So in general, we assume that for any 2 such bundles, the consumer is able to make one of 3 possible statements. Either she prefers bundle A to bundle B, either she prefers bundle B to bundle A, or she equally prefers A to B. Although preference orderings often differ widely among consumers, most share several important features. So economists generally assume 4 simple properties of preference orderings that again represent this sort of subjective perspective on goods that can be consumed. So the first property of preference orderings that is common to all individuals is completeness. So what does completeness mean? Well, that means a consumer is able to rank all possible combinations of goods and services. So they're able to say that either one consumption bundle is better than the other, or the other is better than the one, or they are equally as attractive as each other. That's what the completeness property embodies. The second one is that more is better. Consumers prefer more to less of anything. Again, this is a very general assumption. Yes, there are in reality exceptions to this, but just in general, just to be as general as possible, again, the assumptions we make are simplifying. They're meant to, just kind of get rid of some of the complexity of the world to be able to analyze things in the best way possible. And they're not always going to be realistic. But the model that we use here is powerful. And even though the assumptions we make to get us to the conclusions that do correlate with reality and do help us understand it better are maybe a little bit too simple and maybe somewhat unrealistic, it doesn't negate the power of the model and its overall effect. So you just kind of got to go with it. And it's okay to be critical because, yeah, definitely criticism is important. And we should always be thinking critically about the things that are introduced to us, but also to understand that, ideas can coexist. Complexity can coexist with simplicity as long as we understand the context in which we're working. All right, so more is better. Other things equal, more of a good is preferred to less of a good. As long as people can freely store or dispose of goods they don't want, having more of something can't make them worse off. The third property is transitivity. So this is my only chance to put Star Wars into this class. So if you like Star Wars The Force Awakens more than you like Star Wars Return of the Jedi, and you like Star Wars Return of the Jedi more than Star Wars The Phantom Menace, then you certainly like Star Wars The Force Awakens more than you like Star Wars The Phantom Menace. Transitivity. If you prefer A to B and you prefer B to C, then you prefer A to C. Transitivity is a consistency property and applies as well to the relation equally attractive to and to any combinations of it and the preferred to relation. Just, of course, yeah. So if A is equally attractive as B and B is equally attractive as C, we can also say, based on our transitivity assumption, that A is equally attractive as C. So transitivity works in that scenario as well. Similarly, if A is preferred to B and B is equally attractive as C, then it follows that A is also preferred to C. And then finally, convexity. Convexity means we like a mix of things versus just like extremes. So mixtures of goods are preferable to extremes. Suppose you're indifferent between a bundle that has 4 units of one good and 0 of the other, or 0 of one good and 4 of the other. If your preferences are convex, then you will prefer the bundle that has 2 of each of the goods to each of the more extreme bundles. This property conveys the sense that we like balance in our mix of consumption goods. All right, so these assumptions about preference orderings enable us to generate a graphical description of the consumer's preferences. All right, so consider first this bundle. Again, we're in this world where only food and shelter are available to be purchased and ultimately consumed. So consider bundle A. It has 10 units of food and 12 units of shelter. The more is better assumption tells us that all bundles to the northeast of A, like Z, are going to be preferred to A because more is better. So A is preferred to all those to the southwest of A, like W. So again, more is better. So like any of these bundles over here, A will be preferred to those because A has more of them. So A reflects the more is better property. Consider all bundles along the line that joins Z and W. So there's a bunch of bundles between them. Going along the line, we're likely to encounter a bundle that is equally preferred to A, right? We know that that to the southwest of A is preferred to all of those, and we know that to the northeast of A, all of those are preferred to A. If A is preferred to W, then at some point we have to cross over from the bundles that A is preferred to those that are preferred to A. So at some point along these, there has to be one bundle that is equally preferred to A that kind of makes that transition. So if we let B denote the bundle that is equally attractive to A, in precisely the same fashion, we can find another point. We can call it C that is equally attractive to B. So by the transitivity assumption, we know that C is equally attractive to A because B is equally attractive to A and C is equally attractive to B. So therefore, A and C are equally attractive to each other. So we can repeat this process as often as we like, and the end result will be to connect the points and get to what's called an indifference curve. A set of bundles, all of which are equally attractive as the original bundle A, and hence also equally attractive as one another. So along this curve, all the bundles representing combinations of the two goods in this two-good world, made up of food and shelter, are going to be equally preferred to each other. Any of the bundles to the southwest of this curve will be less preferred to any of the bundles along the indifference curve, and any bundles to the northeast of the curve will be more preferred than any of those along the indifference curve. But any of the bundles embodied in the indifference curve, one will be indifferent between, right? They will be as happy consuming this bundle over here to maybe that bundle over there, and any in between that's on that line. So again, an indifference curve is a set of bundles among which the consumer is indifferent. An indifference curve also permits us to compare the satisfaction implicit in bundles that lie along it with those that lie either below or above, as I mentioned. It permits us, for example, to compare bundle C to bundle W. In general, bundles that lie above an indifference curve are all preferred to the bundles that lie on it, as I already mentioned. Similarly, bundles that lie on an indifference curve are all preferred to those that lie below it. So the completeness property of preferences, again, the fact that you are able to rank all the possible options, in this case, bundles of these two goods, either one is preferred to the other is preferred to one, or they're equally preferred to each other. The completeness property of preferences implies that there is an indifference curve that passes through every possible bundle. And therefore, there's an infinite amount of indifference curves. We don't see them, but they're all there, representing, again, combinations that are of the two goods, consumption bundles that are equally preferred along an indifference curve, and the consumption bundles of the higher indifference curves are preferred to the consumption bundles of the lower indifference curves relative to the origin here. So as we move out, the indifference curves embody bundles that are more preferred than indifference curves that are closer to the origin. So all of these indifference curves make up the indifference map. The indifference map is a graphical representation of a consumer's preferences. So it's a representative sample of the set of a consumer's indifference curves used as a graphical summary of her preference ordering. So again, we have to set up the trade-off that like the markets set up for us in terms of what we can buy, and that is embodied in the budget constraint. The trade-off in the slope of that budget constraint is the relative price, the exchange price of goods in markets. But we have to interact that with our own preferences. How much are we willing to trade off one good for another? And that trade-off will be embodied in the slope of the indifference curves. So the indifference map shows just 4 of the infinitely many indifference curves that, taken together, yield a complete description of the consumer's preferences. So the numbers I1 through I4 are index values used to denote the order of preference that corresponds to the respective indifference curves. Any index numbers would do equally well provided they satisfy the property that indifference curve 1 is preferred to indifference curve 2, is preferred to indifference curve 3, is preferred to indifference curve 4. So we have increasing satisfaction as we move out from the origin. In representing the consumer's preferences, what really counts is the ranking of the indifference curves, not the particular numerical values we assign to them. So we say that the ranking is ordinal and not cardinal. There's nothing inherently of value in like the numbers we give them, as long as they're just ranked in the order of preference. So this could be 10, this could be 1,000, this could be 1,000,000, this could be 1,000,000,000, and it wouldn't mean anything different than what we see here already. So that's ordinal versus cardinal. So these 4 properties, completeness, more is better, transitivity, and convexity of preference orderings, imply 4 important properties of indifference curves and indifference maps. The first one is that indifference curves are ubiquitous. Indifference curves are everywhere. Any bundle has an indifference curve passing through it. This property is assured by the completeness property of preferences. All bundles must be able to be ranked. The second property of indifference curves and indifference maps, indifference curves are downward sloping. So they always need to sort of have this like negative relationship that embodies a trade-off. As we consume more of one good, we give up some of the other good. An upward sloping indifference curve would violate the more is better property by saying a bundle with more of both goods is equivalent to a bundle with less of both goods. So again, like all bundles along an indifference curve, one is indifferent between them, but this bundle over here has more of both goods than this bundle over here, which violates the more is better assumption. Therefore, indifference curves have to be negatively sloped. Indifference curves from the same indifference map cannot cross. So here we have 2 indifference curves. I colored one in blue just to demarcate them from each other. So to see why, suppose that 2 indifference curves did in fact cross, the following statements would then have to be true. E has to be equally attractive to D, so this consumption bundle has to be equally attractive to D because they are on the same indifference curve. D is equally attractive to F because they are on the same indifference curve. And therefore E has to be equally attractive to F by transitivity, which is impossible. But we also know that F is preferred to E because more is better, and therefore it's impossible. So it's not possible for statements 3 and 4 to be true simultaneously, implying a contradiction. So again, indifference curves cannot cross. And finally, the fourth property is that indifference curves become less steep as we move downward and to the right, embodying the convexity property. This property is implied by the convexity property of preferences and will be fleshed out in the next section, in which we talk about this trade-off that is embodied in the slope of the indifference curve. All right. So an important property of a consumer's preference is the rate at which he or she is willing to exchange or trade off one good for another, right? So in the marketplace, if you're using all of your income and you're consuming on the budget constraint, then in order to consume more of one good, you have to give up some of the other good. As far as your preferences go, in order to give up to consume more of one good, you also have to give up some of the other good in order to remain indifferent between the bundles that you're consuming. So there's a trade-off that is also implied by the curvature of the indifference curve. So the rate at which a consumer is willing to exchange or trade off one good for another is called the marginal rate of substitution, which is just a way of describing the slope of the indifference curve, the marginal rate of substitution. It's defined as the absolute value of the slope of the indifference curve at a point. With the budget constraint is a straight line. That means it has a constant slope. That means the opportunity cost or the relative price of the goods doesn't change. But we see that the slope is changing as we move from left to right on the indifference curve. So the marginal rate of substitution is not constant along an indifference curve. It is changing. But at any given point, we can define it. So the marginal rate of substitution at any point on an indifference curve is the rate at which the consumer is willing to exchange the good measured on the vertical axis for the good measured along the horizontal axis, and it's equal to the absolute value of the slope of the indifference curve. So here at point A, there's a rate at which this consumer is willing to trade off shelter for food. It would be the slope of the line, the tangent line to this point. And we can represent that in this case as a 2-to-1 exchange. So the marginal rate of substitution for this consumer at point A is 2, meaning that they're willing to exchange 2 units of food for 1 unit of shelter to remain as happy as they were, as satisfied. So again, the marginal rate of substitution at point A is the change in FA, the amount of food, at that point with respect to the change in shelter at that point. If the marginal rate of substitution at A is 2, this means the consumer must be given 2 pounds of food to make up for the loss of 1 squared yard of shelter in order to remain indifferent. The convexity property of preferences tells us that along an indifference curve, the more a consumer has of one good, the more she must give up of that good before she will be willing to give up another unit of the good. So what this reflects, and what I'll talk about more when we get to introducing utility into this, is diminishing marginal utility. So if you remember from economics, your microeconomics course, each additional unit that we consume makes us happy, but not as happy as the last unit, right? So if you're starving and you eat 1 piece of pizza, you love it. It's incredible. The marginal utility is really high. But the 10th slice of pizza, you're happy, but you're certainly not as happy as at first. You're certainly not as happy as the second or the third. You have diminishing marginal utility. So what this basically tells us is that earlier units of any good consumed are going to be valued more in terms of satisfaction than later units of the good. So here we see that at this point, where 3 units of shelter and 17 units of food are being consumed, you're not consuming a lot of shelter. So 1 unit of shelter is worth a lot in exchange for food in terms of your own subjective preferences that are being modeled here. And when I say you, I'm talking about the general you. As more shelter is consumed, shelter is not valued as much. And so therefore, in terms of your subjective rate of exchange, the marginal rate of substitution, you're willing to trade off 1 good for another to remain as happy as you were. It has gone down. So now 1 unit of shelter is only worth 1 unit of food. And then as we get to this 16th unit of shelter, that extra unit of shelter is only worth a 1/4 unit of food. So indifference curves with diminishing marginal substitution is what we're looking at here. Reflect the convexity, are thus convex, or also another way to define it is bowed outward. So kind of like a bow, like you would use to shoot an arrow. It's bowed outward from the origin. So diminishing marginal rate of substitution is embodied in this shape, the convex shape of our indifference curve. Diminishing marginal rate of substitution means that consumers like variety. We're usually willing to give up goods we already have a lot of to obtain more of those goods we now have little of. All right. You can represent different people's preferences with slightly different shaped indifference curves that will have different marginal rates of substitution. So suppose, for example, both Tex and Mohan like potatoes, but Mohan likes rice more than Tex does. So here are Tex's preferences, and here's Mohan's preferences. Remember, Mohan likes rice more than Tex. So if we're at point A, Mohan is willing to trade off 3 units of rice for 5 units of potato. So he values rice pretty high relative to, I'm sorry, no. So we're at this point here. That's the starting point. That's the starting point. Okay. So in order to give up, to get an extra unit of rice, Mohan has to give up 2 units of potato. So he values 1 unit of rice subjectively as much as 2 units of potato. Whereas Tex, because his indifference curves are flatter, he doesn't like rice as much, and that is embodied in the difference in marginal rate of substitution. So going from this point, to get 1 extra unit of rice, he's only willing to give up 1 potato. So what this is meant to highlight is just the fact that like you can represent different consumers' preferences by the shape of the indifference curve, ultimately the equation that you would use to represent it. But like these models are flexible. Like you can adapt them to different situations. So you can think about a market where you have consumers that, you know, are more interested in one thing versus another, and you can incorporate that into your model to be a little bit more specific about how that might affect the price of whatever it is you're interested in. And so this is a way of representing that. And this is how the marginal rate of substitution, again, the slope of the indifference curves, which are part of our indifference map, can capture complexity. So I just mentioned all that. All right, we're done for today. So I hope that wasn't too much, but hey, it is what it is. We're going to move forward on Thursday with the equilibrium, interacting the preferences with the prices and income to get us to that optimal point of consumption. And then on Tuesday, we'll do the calculus to kind of represent the same thing. All right, have a good couple of days. I will see you on Thursday.